Okay, so thanks for that introduction. Uh, I will start with a very quick introduction to the Geospatial Commission and also to myself. So the Commission was created in 2018. Its aim is to help unlock the significant economic, social and environmental value associated with location data. Its formal status is as an independent expert committee within Cabinet Office. And we work closely with partners in both the public and private sectors. We have particularly close links with the Geo6. That's the British Geological Survey, the Coal Authority, HM Land Registry, Ordnance Survey, the UK Hydrographic Office and the Valuation Office Agency. Those are the public sector bodies that hold significant amounts of location data. We set the UK's strategy for location data, and we published our first such strategy earlier this year in June. We have a variety of levers available to deliver that strategy. So, for example, we manage the contracts which provide the public sector with access to location data. And where appropriate, we can facilitate innovation by the private sector, perhaps through targeted investments in specific data projects, or by encouraging collaboration on matters such as data sharing and standards. As for myself, my background is as a technologist working in telecommunications. I spent about a decade as Ofcom's Chief Technology Officer and the last few years as a board member. Before that, I worked in the private sector designing wireless networks, and I have a particular interest in how data and connectivity can be combined to create new services. That's something which is very relevant to this conference. Okay, so let me start by talking a bit about some work we've carried out already. Some examples on this slide of work to date. So firstly, we've negotiated a public sector geospatial agreement with Ordnance Survey. This provides more than 5,000 public sector organisations unlimited access to Ordnance Survey data at a value of around £1 billion over a period of 10 years. Importantly, we've also used that PSGA process to open up access for a wider set of users, private as well as public sector. For example, firstly, the existing Ordnance Survey open data product has been very popular and has now been made easier to use since it can be accessed via an API. Secondly, important elements of Ordnance Survey's detailed master map, such as key identifiers, are now completely open. And finally, other master map data is made freely available up to a transaction threshold and also under a development license. So those are all examples of opening up access to data held by the public sector, which is extremely important. But as I've just noted, we're also keen to understand how we can facilitate sharing of data within the private sector. And as an example, we've just completed 2 successful pilots in the northeast of England and in London to test a national underground asset register. That's a digital map of all underground pipes and cables. There are significant benefits associated with such a register in terms of more efficient street works and reduced disruption. But there are also legitimate reasons why utility companies might be reluctant to share the data required to build such a register. In particular, there are likely to be concerns around both security and commercial confidentiality. The fact that it was possible to address these concerns during the pilots was a great outcome for the project. And importantly, it suggests that similar collaborative approaches might work elsewhere. Now, moving forward, our key priorities will be informed, as I've already mentioned, by the UK Geospatial Strategy, which we published in June, which I illustrate on this slide. You won't be surprised to see that we identified transport as a key opportunity for the exploitation of location data. It's a sector which faces some obvious challenges, given its importance to both economic growth and environmental targets. And the sector will be central to any post-COVID green growth agenda. But it's also a sector where there's already a great deal of innovation and potential for more, enabled in part by location data. Perhaps unfashionably, I'm an optimist when it comes to the use of technology to meet big challenges. Right now, we at the Commission are at the stage of working out where we should focus our resources to make sure we can really make a difference. We're conscious that lots of work is already underway in this space, and I'm entirely comfortable with the idea that sometimes the best thing a government body can do is not get in the way. So to work out where we should focus our efforts, we've set up a new Transport Location Data Task Force, which I chair, which brings together a variety of experts from across the public and private sectors. We've also launched a £2 million transport location data competition, working with Innovate UK, to stimulate new ideas as to how location data can enable innovation in mobility services. So let me say a bit more about the work of the task force. As you'll all know, the transport sector is a complex ecosystem, and that's illustrated on this slide. Don't worry about the detail on this slide. All I really want to communicate is there's lots of stuff we could look at. What we've chosen to focus on is 6 specific use cases. These use cases are shown at the bottom of the slide. They're important in their own right, and they're also likely to highlight themes which have wider relevance. In a minute, I'll talk in a bit more detail about a couple of them. That's electric vehicles and road and rail haulage. But let me first make some quick comments on the others and reading across the slide. So, connected and autonomous vehicles. That's, of course, an idea that sparked a lot of technical interest, but it's a bit unclear, at least to me, where it's headed, especially compared with the push for electrification, where the goals are very clear. I think we need to understand what are the most important benefits that connectivity and autonomy will deliver, and what combination of connectivity, local intelligence in vehicles, local sensors, and location data is required to deliver those benefits. Then, as to road infrastructure, there is a clear need to reduce congestion, improve safety, and increase efficiency. And data is an important and obvious enabler of means to fix that need, whether that's designing roads or facilitating more efficient use of roads, for example, through ride sharing. There's also a particularly interesting question as to how road use may change post-COVID, where we'll need to understand shifts in behaviour. Those shifts might, for example, include reduced commuter traffic and more deliveries. Again, data is essential to understand those shifts. Then there are ambitious ideas around the use of drones. Drones might remove the need to send a van out to deliver a parcel to a single house, or they might enable the rapid delivery of medical supplies. But a drone will need to be told where it's allowed to fly, the buildings it needs to avoid, the wind speed it's likely to encounter, and the precise location of its destination, all in 3-dimensional space. Clearly a new type of data set. And finally, location data is already widely used for route optimization, but we can see new applications emerging, all of which require new forms of data. These range from helping drivers find and reserve parking spaces to protecting clean air zones by routing traffic around them. So let me talk about one specific case study, and that's electric vehicles. As I don't really need to say for this audience, electric vehicles, that's an innovation which is transforming the automobile industry. That's illustrated by the fact that Tesla recently overtook Toyota to become the world's most valuable car manufacturer. Personally, slightly skeptical about such valuations, but they certainly illustrate the disruptive potential of electric vehicles. And location data can be used in various ways. Importantly, given the size of the electric vehicle market, a modest incremental value enabled by location data can still be very substantial in absolute terms. One obvious example of the use of location data is as an input to the design of charge point networks, a completely new infrastructure without which electric vehicles are just large lumps of metal. Questions we'll need to consider include: how many charge points are required to meet demand? Where should they be located in order to maximise convenience? And the question of convenience is particularly important for those people who can't charge electric vehicles overnight at home. Where should charge points be located in order to minimise the cost associated with extending electricity distribution networks? And there's an interesting question as to whether the batteries in electric vehicles could be used as a means of storing electricity to spread the peak load on generators. Finally, are there synergies with other infrastructures which require power, such as mobile base stations? Clearly, all of these questions require data. And then once the infrastructure is in place, the main barrier to take up of electric vehicles is likely to be range anxiety. The best way to address this might be to provide drivers with real-time information on the availability of charge points on their route and make it possible for them to reserve a slot at a charge point. Finally, there's a set of questions about how to maximise the efficiency of electric vehicles. I particularly like the idea that detailed data on road geometry, gradients, curves, and so on could be used to improve efficiency and increase range. And that could be achieved by maximising the use of regenerative braking. In other words, anticipating the need to slow down so that as much as possible of a car's kinetic energy is stored as electricity rather than dissipated as heat. Moving on to my next case study, road and rail haulage. This is an area where telematics combined with other forms of location data can deliver very significant improvements in efficiency and also help meet environmental goals. So data on where freight vehicles are, what they're carrying, when that freight needs to reach its destination, that's all important for route planning. And that type of planning, of course, already happens today, but there's clearly scope to do more. For example, through more effective sharing of existing data sets. Then there are some interesting ideas about how freight networks might be redesigned to improve efficiency. That might include aggregating freight so that it can be carried more efficiently over long distances, making use of rail as well as road, and also aggregating local deliveries to reduce the number of delivery vans in our cities. Clearly, all of this requires data. Then from an environmental perspective, any efficiency improvements will of course help reduce the amount of fuel used, but we could go further and explicitly optimize routes to minimize the use of fuel rather than minimize journey time, as is typically the case at the moment. Doing that would require data on factors such as the optimum speed for fuel efficiency for different vehicles, the typical speeds at which vehicles drive on different roads, road gradients, and so on. And finally, there is the potential for very significant improvements in safety. I've heard it estimated that around 80% of road accidents might be avoided if the driver of a vehicle had better information on what's around them. That's a car just around the corner, a bicycle in a blind spot. If a driver just knew about those things, it might be possible to avoid a potential accident. Another interesting potential area is that we could design safer road junctions if we use data on vehicle braking to tell us which junctions had lots of near misses. We could then improve the design of those junctions before someone gets hurt rather than after, which will be a fantastic application of location data. So I'll stop there. I hope I've given a sense of the range of opportunities we're interested in to use location data to release value, improve the environment, and make our roads safer. Do let us know if there are any specific areas you think we should focus on. Looking forward to hearing some questions. Bye now.
Thank you, Steve, and a fantastic presentation. Thank you for that. A really good summary of the focus of the Geospatial Commission and a couple of very relevant use cases there, so thank you. And also say thank you to Seb for his presentation. If we could ask you both to join us on stage, and we'll work through a couple of questions that we've got lining up in the Q&A panel just before the 2-minute silence. Hi, Steve.
Hi there.
As you're first on stage and waiting for Seb to join us, let's get cracking with some of your questions. What have we got? Top there. Yeah, okay. So you mentioned 9 location data opportunities: transportation, infrastructure, housing. So do you have of those 9, do you have an ordered list of priorities for these opportunity types?
No, not a strictly ordered list. What we're trying to do is identify use cases under each of those headings where we think we can make a real difference. All of those areas are important. What we have to work out is practically, how can we best use the levers we've got. In doing that, I'd expect that in each individual use case we think about, it's good to have something to provide focus, but I'd expect what we learn from each of those use cases will also have more general applicability. Just to give an example, that was the case for the National Underground Asset Register, which was focused on one particular issue, but where, as I mentioned in my presentation, the idea that we could facilitate private sector data sharing, of course, has much wider applicability as well. Yeah, okay. So the concept that some of these use cases will have, you'll be able to reuse or at least have learnings across a number of those different sectors. Yeah. So I suppose that's implicit in the naming. You've got transportation, but then you've also got a focus on infrastructure, and by virtue, there's connections between the two. Yeah. Interesting. Yeah. Okay. Nothing's independent. I mean, all of the use cases within transportation, we end up discovering the obvious linkages and the same types of questions come up. But that's sort of reassuring, actually. Yeah. Well, it gets to that sort of system of systems interconnectivity, which is what we're striving for. Okay. So thank you for that. So working through, what else have we got? I think you touched on it just now, but let's just answer the question. So Geospatial Commission selected 6 use cases. I mean, how did you prioritise those above? I think it was a big stack of them in under 3 main pillars under mobility. How did you prioritise those 6? Well, I mean, the starting point is we had to select something. If we tried to do them all at once, we'd have been doomed. So there's something about focus. In selecting them, there's a combination of what's the total potential value, if you like. So, electric vehicles, it's a massive sector, so even an incremental difference has real value. But there are also some other areas which are much more speculative, drones as an example, but where that will go nowhere without new data sets. So if the data side of it is really important. So it's a combination of potential impact and our ability to make a difference. But I would also say there's no magic about it. I'm sure there'd be good arguments for selecting other use cases. Yeah. We need to start with somewhere. Yes. Yeah. Okay. It's not boiling the ocean and trying to find something that. Yeah. Well, I'm a great believer in trying to. And from a policy perspective, there's always a sort of top-down, bottom-up. It's always good to have a practical problem to solve. Yeah. Because otherwise you can just go off on flights of fancy. Yeah. But it's also usually the case that what you learn from that practical problem can be applied more generally. Yeah. I mean, just out of interest, I mean, you've had one of those. You mentioned one of those use cases, the National Underground Assets Register. I mean, what were off the top of your head? What were your main learnings that you could apply from that use case? It was mainly. It was really the process of engaging with companies who have mixed incentives. The bottom line is that most utility companies get some benefit from data sharing, but particularly the companies that compete with each other, and actually that's particularly an issue in telecoms where, say, BT and Virgin Media compete. There is they worry about sharing data because they're giving away data on their networks. That's their source of their competitive advantage. So it's trying to find a way to get those companies sharing data which is commercially confidential, but where there is also a benefit to them and to others from sharing that data. And designing a system which maximizes the benefits from sharing and minimises the downside from a commercial perspective. That's, I think, what we learned a lot about, and that's, I think, what has wider applicability elsewhere.
Yeah, it's strong learnings, isn't it? Because that's always been the challenge, definitely within, say, utilities. Getting you guys to play ball together. And
I have sympathy with them because, you know, their networks are the thing that they have nothing if not their networks. The reach of their networks is the thing which enables them to provide services. So they are nervous about giving away all the detail of that. But there's obviously a wider benefit of knowing where the pipes are.
Yeah. Okay, thank you. Seb's joined us on stage. Hi, Seb. We've got one more question for Steve. So we'll do that before we get to you, Seb, with an eye on the time as well. Yeah. So, Steve, a quick one here. You talked about the SBR competition, and I think you've already answered it, but let's do it. How else do you plan to engage with the market?
The most obvious mechanism at the moment is through this new transport location task force, which we're running in conjunction with DFT. Yeah. What we're doing there at the moment is running a series of roundtables. So the idea is for each of the use cases, we're running a roundtable to try and gather evidence, gather views, and we'll then bring all that together in a few months' time once we've got the evidence. We're also, frankly, open. If anyone listening has bright ideas, do contact us. Definitely in that evidence gathering stage.
Brilliant. Well, a good plug for the Transport Task Force. With that, Steve, I'd like to thank you for your participation and for Q&A. If you don't mind staying on stage, or you can minimise yourself, I'll move on to Seb.